Okay, so I decided to take this card completely apart, and I'm going to just basically sandblast the whole frame. Start with a fresh new coat of paint. I'm going to also lift these decals and redo them in vinyl. These are going to be done on a vinyl cutter, so I need to lift those. Well, I can do that via the internet with a much better graphic. So I'm going to take a picture and lift it from there, but I'm not going to do that. From this car. Is there a better graphics online? This this control arm here, I forget the name. What this is called? This can be installed upward or facing upwards, so that the links are at the front and not at the rear. The links at the rear are doing this have done this to the frame, and this is almost kind of worn out right through the metal right there. So I'm going to have to put a little bit of metal there, just weld that section there and buff, grind it and buff it. So just to fill in this concave pocket here. Same thing on the other side. So my thought was to just invert this and have the steering control rods at the or the tie rods at the front. I think that would work better. I think it'll clear it just fine, even though it's got this other bar right here. So I just have to adjust the height. So I think that's going to be one of the changes that I'm going to do to the steering. The other thing is this right here. I'm going to have to remove this plate. This is welded, and I don't know why they do this. They just go directly over this steel over steel instead of using some kind of a nylon bushing or even a bearing. Same thing here. This is steel inside steel. Same thing with these steering axles. They go. It's just a rod, a bent rod, L-shaped rod that rides on steel. I guess you're supposed to grease the heck out of these. That's why they have these holes here. That one has a hole. That one has a hole there, and I don't see any holes here. But I guess that's how they did it in the old times. But this car is not that old. I think the company that manufactured this started back in 1996. So I would have imagined that they would have used some kind of a nylon bushing or Delrin bushing. I use Delrin bushings on mine. If you look at some of the electric cars that I built, for example, this one here was my first one that went through several modifications. The front end was one of the first things that I modified, just made it a lot stronger, because originally I had instead of these brackets, these C brackets that hold the spindle bolt and that have the links tied to it with a control arm. I originally manufactured those from the same maker pipe connectors, and I have videos on my YouTube channel under MIA Microflight, which is my company, where I manufacture radio control ultralights, microlights, autogyros, helicopters. I've done, back in the day, but I showed in one of my videos, I showed the early version of this, which was just manufactured, a spindle manufacturer in a super creative way with these maker pipe connectors. But that wasn't so strong, so I ended up making this double bar right here and just going with this setup here. I did have to make my own spindle brackets here. As you can see, that is done with this is 3/16 of an inch steel, and it's done that way right there. But I do use nylon. In this case, I use nylon bushings here to make the pivoting or the kingpin bolt a lot smoother, and so its control is really smooth here. Same thing here. I used Delrin. These are Delrin bushings right here, and I just used a PVC pipe right here to retain this control shaft. similar at the bottom right here. I use Delrin bushing inside this maker pipe connector as the socket for this control rod. So same thing here. This is another card which is a little simpler than this, but kind of same concept, using the maker pipe connectors. And this one only has one. It's a very light, a lighter version, but same thing. I had to manufacture these brackets. I had to weld these C brackets. Same thing I did here. And this inside here has bushings to take up some of the spacing in between the bolt. These are 5/6 3/8 or 5/16 bolts right through the the center of the maker pipe connectors with Delrin bushings. So it's it's a very precise control. There's no wobble right there. If there's any wobble, it's probably in the wheel itself, because these wheels are just Harbor Freight wheels or Amazon wheels. They're not real go-kart wheels. I mean, they're fine for stuff like this, but on something like this, these are real wheels. They're real go-kart wheels. So that's same thing here on this other one that I have here that I made with a 1.5 inch square steel tubing. This tubing is used. Home Depot was selling these for gate posts, for RV gate posts. So I bought a bunch of these because I thought I was going to do the whole gate. I was going to remove the old smaller framing from one of the gates. It's an RV gate that's on the side of my house here, and I was going to just redo the whole frame, but I ended up not doing that because the frame was still good, and all it needed was just the main posts that support the hinges. So I ended up keeping about 10 of these tubes. I went back recently to Home Depot to see if they had any more of these, and I don't see them there, and I don't see them online. So I think they stopped making this 1.5 inch square tubing. When you buy, I guess you can find these in industrial metal supply places. You can find pretty much anything, any size tubing. But I really like these, because they're very lightweight. And with brackets like these are brackets from Amazon. These are 3 millimeter thick brackets, solid brackets, T brackets. I was able to assemble this cart fairly quick. Of course, I had to manufacture, like I said, these spindle control arms, C brackets here. And I had to weld that. So my welding is not very extensive, but I had already a little bit of training, I suppose, with the gate that I welded some of these tubings and additional brackets to reinforce that on the concrete blocks that hold the hinges. So I got a little experience there, and when I went to do these, I just made sure that the parts were super clean. And after welding this, I came back with a grinder and just rounded that off, so it looks really, really professional. Anyway, so that's the other thing that I'm going to do here is I'm going to either make these more robust, which is an easy fix. Just remove these, put a bigger tube here so that I can still use those L-shaped bolt-on spindles, but it'll give me a little more room. This tube is wider. It'll give me more room so that I can insert a Delrin bushing there inside. Same thing here. This should have some kind of a bushing because this rattles right here. So if I put a bushing, this I guess I don't need to take this out. I mean, I can do a bushing, a split bushing here, so where I can just split it and just put the two halves inserted in there, and it'll work just fine. This one right here will also need to have some kind of a bushing here, because I just don't like steel riding on steel without some kind of a lubricating material. Delrin has self-lubricating properties, so it's a good material to do this, as well as nylon. You can use nylon as well, or you can also use bronze bearings. Bronze bearings I don't like because they do wear out faster, in my opinion, than the Delrin bushings. So those are the things that I'm going to be upgrading here. The sprocket here, and I call this the if you're familiar with the gears, you have the pinion, which is a smaller gear, and then you have the spur gear, which is a larger gear. And so I'm calling this the spur sprocket. I don't know if this has any particular technical name as it applies to go-karts, but it's just a sprocket drive gear, I guess. But I found out this is actually 45 teeth, and the smaller one is 10 teeth. So we have a 4.5 to 1 ratio here, gear reduction here for the motor. So, the motor spinning 3,500 RPM, you can figure that out. 3,500 RPM for every 10, for every one full rotation of the 10-tooth gear, this is going to spin 4.5 times. It's going to spin 4 times slower. So you're actually dividing, the 3,500 RPM of the engine divided by 4.5, and that's your output here, your RPM for the. So basically, what you're doing is you're taking the high speed and turning it into a slower speed with high torque, which is what you need, for a car of this nature, because this is a heavy, heavy car. So. I did a little more work on my CAD model. I took some additional measurements and some refinements here, because the way I had these pipes, I had this pipe all straight right here with a bend right there, so this actually has a little angle to it. I did the roll cage, and that's done. I did that curved support for the steering shaft, and I added I added this plate right here. I still need to do these slats on the plate, and I have to model all the gears and the chain, and all those other components that make up the drive system. The engine, I can probably model also the engine. Just not go crazy modeling every single detail there, but just all the necessary parts, such as the torque converter, the engine block, the torque converter, and the belt and the drive system. The brake is also need to model that. And as I was saying in another video that I did, this is the brake. This is the brake band. This is not a drum brake, but it's I forget what they call these brakes, band brakes, I guess. The band actually just clamps onto the brake that brake part right here, the hub, and that's what stops the car. I mean, it's pretty effective way to provide braking. But I also have some disc brakes that I could install here, and which are a little bit better than this stuff right here. But this stuff works. I just need to replace this band right here. I do have an order for this band, so I'm going to be replacing that. These parts right here, these are the steering axles, or what would you call this? The spindles. So it's just nothing more than just I think these are 3/4 or 5/8 diameter steel with threaded ends here. One for to support it on that tube right there, the pivoting tube, the king post, or the kingpin post. So this is the kingpin, and this is the axle. It's just just a curved section right here, which is it's surprisingly pretty strong. It's got this this little bracket here for to attach the control links or the tie rods, and you can either do it at the front, this is set up for, or at the back, as I was or at the back or at the front rather, because this was set up for the back control, back steering. So I plan on doing it with the control at the front, just to gain a little more and maybe increase the length of this pitman arm. I just remember the name. They call this pitman arm. So if I increase this plate right here, I maybe just weld another little piece here, and then just move these holes up by another ½ inch, I think I'll have a little more torque via the steering, so it's not so hard to steer, because that little wheel and that short pitman arm, it's very hard to steer this. Once the car gets going, it's a little bit easier to steer as it gets moving, but if you're running slow, it's very, very, very hard to steer this. You're really putting a lot of effort into it. The seat is, I took out the seat. The seat is just sitting right there. So this seat is a pretty cool seat. It's got these sliders here, so you can adjust front to back distance. I have to model this. I have to take some dimensions and put that on CAD. But I'm getting pretty close, to finishing this on the CAD model, which is something that I wanted to do first and foremost before I start modifying this. It's a lot easier to have a model and just the illustration and just plans, that you can work by. Since I wasn't able to find a manual for this particular model, I know that there are similar models out there, more modern ones that reuse some of the same parts. Just by looking at some of the models that are at BMI, I think it's called BMI website. BMI is a company that I believe also sells replacement parts. But somebody sent me the link there, and I actually had stumbled on that website before I joined do-it-yourself go-karts. So this is where I'm at right here. Today I'm waiting for the sockets so that I can remove these back wheels. That's a 1.5 inch socket. I have all sorts of sockets, but I just didn't have that particular size. So I'm waiting for that, and once I get that out, once I get the wheels out, I'll be able to remove the axle here and completely remove that section. Remove the axle with the sprocket and the chain, and so that'll leave me just the frame itself. Now, this roll cage was actually it's actually meant. I don't know if this was meant to be welded here. I think the previous owner or whoever had this originally welded this just to make it more sturdy, and that's actually acceptable. And I would have done the same thing, just to make this a lot more secure, because the way this was originally designed, I think by the manufacturer, was just put with this C bracket here and a bolt, just to bolt this down and be able to take it out. But I believe whoever had this, the first owner, second owner, whoever had this, they actually welded these sections here. They just kind of, these are sort of tack welds, but these are more complete welds, at these sections right here. This is not welded, so this can be easily removed here via these two bolts right here. So I can take that out, and this will lift. I believe I can, if I just take my grinder and cut that section out, I can remove the roll cage, and that would make it easier also to sandblast this and paint it if I go that route. I have to get some quotes on powder coating and see who can do this at what price. I don't want to go crazy here. Spending all kinds of money that I don't need to. So, but I would really like to have this powder coated. The frame is intact pretty much, aside from a couple little areas like I mentioned. These indentations here from the tie rods, they wore out the metal. But I think with a little bit of metal there, welded metal, I think that and grind it nice and smooth, I think that'll be fine. Yeah, powder coating would be ideal here, but I think if this is also sanded, thoroughly sanded, sandblasted, and primed, with a good primer as a base, and then coating of paint, I think that might suffice and might be a lot cheaper than powder coating. I've never had anything powder coated, so I don't know what the prices are. I'm assuming they might be a little more, considering that it's a more durable method of applying paint to a structure, item or device, aircraft, vehicle, whatever. So, yeah, so I thought I'd do this video just to talk a little more about this. And I mean, I've been posting photos of this cart online, but I think this video, is a little more informative, considering, and I'm doing this considering, like I said, that there are no manuals here. So I want to capture as much of the card, the shape, and all the information that I've been posting. With the specs. I'm making my own specs. I'm making my own. I'm putting my own data there as I come across this. Also, I really appreciate people posting comments and giving me some feedback and information. On the same thread. So thank you, all you guys that have been posting. And I mean, I'm pretty savvy when it comes to mechanical things. It's not like it's not my first time, but I'm just not familiar with gas engines. I understand how a gas engine works, but I just have not had the opportunity to get into the details because I don't use these things. Most of the stuff that I build is electric. I mean, I can tell you everything and anything on electric and how that works and what you need in terms of power. But when it comes to gas, this is my first gas go-kart. Actually, my first gas fun project. So bear with me as I'm also learning, these things. The gas, the components in these go-karts. The torque converter. I mean, that's obvious by the name. It's common sense. It just converts. Converts the engine. It's a torque converter. It's a conversion of the torque of the motor. High speed, to low speed, and of course, the belt has to engage at high speed, just for safety. I do understand that. I mean, it's common sense logic when you analyze these things. But as far as governor, I believe this is an arm for the governor, which is some kind of a gear system that sits inside the engine, and I think that adjusts depending on the speed of the motor. On this particular one, this is a tie wrap right here, this arm right here. I guess the link, the original link to the gas was right here via this governor arm. But whoever had this, it looks like, I don't know what this looks like, just a blob of metal there. It looks like they bypassed this somehow. I'm not sure exactly how that works. I need to learn a little more about that. But the control to the gas is actually right here for this one right here. It's just we have this link, and this was I think this was loose right here, so I was having a little trouble getting it to idle just consistently because I think this was slipping right here. I think this needs to be inserted there with some kind of a clamp here, and then the link itself, the cable, the steel cable inside this sleeve here is the thing that pulls it opens up and closes, the carburetor throttle. So in my next video or photos, I think I will have this already prepped, for painting or maybe just paint it. So stay tuned for more.